Hey everyone, today we're going to talk about error measurement and linear regression. We have case scenario 1. Case scenario 1, improving sports performance. Optimizing the angle of a soccer kick. Your school's soccer team is preparing for the championship and they need to be optimize their free kick strategy. By analyzing the results of practice kicks at different angles, your group can provide data-driven advice to the coach on the best angle to use during the game. We perform the experiment 10 times for each angle, 30 degrees, 45 degrees, and 60 degrees, and record their distance. And we have the angles and the distance. 30 degrees, 5.1 meters, 5.0 meters, 4.9 meters, 5.2 meters, 5.1 meters, 5.0 meters, 1.9 meters, 5.2 meters, 5.1 meters, and 5.0 meters. And we have 45 degrees, 6.5 meters, 6.4 meters, 6.6 meters, 6.5 meters, 6.6 meters, 6.5 meters, 6.4 meters, 6.5 meters, 6.6 meters, and 6.5 meters. And lastly, we have 60% degrees, 5.8 meters, 5.7 meters, 5.9 meters, 5.8 meters, 5.9 meters, 5.8 meters, 5.7 meters, 5.9 meters, 5.8 meters, and 5.7 meters. We have the objectives. A. Statistic analysis, mean variance and standard deviation for each angle. B. Linear regression, relation between kick and quick angles and distance. C. Measurement errors, potential errors and their impacts. To do this, calculate for each angle, mean variance and standard deviation. 2. Apply linear regression to understand the relationship between the angle and the average distance. 3. Discuss measurement errors and their impact on the data. And we're gonna go deeper to statistic analysis. Static analysis is the process of collecting and analyzing large volumes of data in order to identify trends and develop valuable insights. Statistical analysis have steps. So step 1, calculate the mean for the angles. And the mean is the average given is n is calculated divided the sum of given numbers by the total of numbers. We have x equals parenthesis open x1 plus x2 plus x3 and so on, close parenthesis. And then we're gonna bring down the given based on the presentation. So that will be 30 plus 45 plus 60 and close parenthesis and divide by 3. And that will be 45. And then the next step is to create a table. In the second column, find the difference of the given data and the calculated mean. In the third column, square the results of the second column. We have the x angles, that would be 30, 45, and 60, and then x over x bar, and lastly we have x, and last we have open parenthesis x over x bar squared. Together 30 angles, and then negative 15 and 225, and the 45 angles or degrees, that will be 0 and 0, and lastly 60 angles or degrees, 15 and 225. And step 3, we calculate the variance. Variance is the expected value of the square variation of a random variable from its mean value. In probability statistics, informally, variance estimates how far a set of numbers are spread out from their mean value. It could be random as well. We have sigma squared equals capital sigma, open parenthesis, x over x bar squared and n. So that would be 450 divided by 3. So the total would be 150. And then with the step 4, we calculate the standard deviation. Standard deviation, the deviation of the values or data from our average mean. Okay, we have standard deviation, square root of standard deviation, and next we have standard deviation equals square root of 150. So it would be standard deviation equals 12.25. So the measure would be x equals x bar plus minus standard deviation. So it would be x minus 45 plus minus 12.25. And then the step 5 is we calculate the mean, variance, and standard deviation for each angles. We have angle 30, x equals open parenthesis 5.1 plus 5.0, 4.9, 5.2, 5.1, 5.0, 4.9, 5.2, 5.1, 5.0, close parenthesis divided by 10. So the total would be 5.05. And then the angle 45 of x open parenthesis 6.5, 6.4, 6.6, 6.5, 6.6 plus 6.5, we all those together, close parenthesis divided by 10, that will be 6.5. And then lastly we have angle 60, 5.8, 5.7, 5.9, 5.8, 5.9, 5.8, 5.7, 5.9, 5.8, 5.7 meters, close parenthesis divided by 10, that would be 5.8. And lastly we have the video.
Okay, so welcome to Mathstoria, and let's have this problem. So given the scores of the students, then find the mean, the population variance, and the standard deviation. So we're going to use a table to solve for this problem, and these are the scores. Then to solve for the mean, so we just need to add all these numbers. So we have 7 plus 11 plus 8 plus 8 plus 19 plus 15 plus 7 plus 9 plus 9 plus 20 plus 17 plus 14 then equals. Then to solve for the mean, we need to divide these total scores by the number of scores. So since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore, this 144 divided by 12 equals, so the mean is 12. Then we need to put this in the table. So this column is for the mean, so that's 12. Then to solve for the population variance, so using this formula, that's over n. For the sample variance, so this one is n minus 1. But since we're looking for the population variance, so therefore the formula is over n. Then since in the formula we have this x minus the mean, so we need to find first the value for this x minus the mean. So that's x minus the mean. So 7 minus 12, this one is negative 5. 11 minus 12, that's negative 1. 8 minus 12, this one is negative 4. 8 minus 12, this one is negative 4. 19 minus 12, that's 7. Then 15 minus 12, this one is 3. 7 minus 12, that's negative 5. 9 minus 12, that's negative 3. 9 minus 12, that's negative 3. 20 minus 12, this one is 8. Then 17 minus 12, that's 5. And 14 minus 12, that's positive 2. So these are now the values for this column. Then in the formula, we have this squared. So we need to square this column. So we have this negative 5 squared. This one is positive 25 because the square of a negative is always positive. This one, negative 1 squared, that's 1. And negative 4 squared, this one is 16. Negative 4 squared, so negative 4 times negative 4, that's 16. 7 squared, so 7 times 7, this one is 49. 3 squared, so 3 times 3, this one is 9. Negative 5 times negative 5, that's 25. Negative 3 times negative 3, positive 9. This one is positive 9. This one is 8 times 8. This one is 64. Then 5 squared, that's 25. And 2 squared, that's 4. Then since we have this summation, so we need to add all these numbers. So we have 25 plus 1 plus 16 plus 16 plus 49 plus 9 plus 25 plus 9 plus 9 plus 64 plus 25, then plus 4 equal. So this is now the sum for this column, that's 252. Then to solve now for the variance, so we need to substitute now the values. So for this summation of x minus the mean squared, so that's 252. Then over n is the number of scores. Since we have these 12 scores, so 252 divided by 12. So to solve now for the variance, so we have 252 divided by 12 equals, so the variance is 21. Then for the standard deviation, so for the standard deviation, so you can solve the standard deviation by the square root of the variance. So therefore, for the standard deviation, that's the square root of 21 because the variance is 21. So to solve now for the standard deviation, so we have square root of 21 equals, so that's 4.58. So the standard deviation is 4.58. So this is now the mean, that's 12. The variance is 21 and the standard deviation is 4.58.